Hello friends, welcome back to my YouTube channel. So in today's video we will see one more problem of unit load method, how to analyze this by using the unit load method. So this is the given problem. Using unit load method, find the horizontal and vertical deflection at free end and take E is equal to 200 GPa and I is equal to 3 into 10 to the power of minus 4 m to the power of 4. So this is our given problem. Here the unit is very important. While analyzing to find out the deflection, we need to put always the unit in meter only. So later we'll convert this. Now we'll solve by using this problem. So first what we have to do is we need to find the support reaction of this. Here point C is free end, we need to find at free end horizontal and vertical deflection at free end. We need to find it, later we'll see. So now we need to find the support reaction of this frame. Now we'll see. At point A fixed end is there. Fixed end usually three reactions takes place. One is vertical, another is horizontal, and one movement takes place. Take it as the clockwise. So now summation of all the moment about A is equal to 0. Clockwise we need to take the positive. So here MA is moving clockwise, I am taking moment as clockwise. MA plus, here 10 kilonewton is also moving clockwise at a distance of 4 meter. So 10 into 4 and UDL is acting there. So UDL of 20 kilonewton, it acts at a distance of 3 meter. 20 into 3 into UDL always act at a distance of L by 2. L by 2 is nothing but half of the distance. So 3 meter half of 3 is 1.5. So 20 into 3 into 1.5 is also moving clockwise. So plus 20 into 3 into 1.5 is equal to 0. Now solve it. MA is nothing but our X plus 10 into 4 plus 20 into 3 into 1.5 is equal to 0. So our X value will come out as 130. So here minus sign indicates what? Whatever the direction we have taken is opposite to this. We have considered initially it was moving clockwise, but the MA is rotate anti-clockwise. Minus sign indicates here it is moving anti-clockwise. So MA value is 130. So make it as anti-clockwise. Here the negative sign indicates it is moving anti-clockwise. So make it like this. MA value is 130. It is anti-clockwise. Summation of all the vertical forces is equal to 0. Upward we need to take the positive. Here VA is moving upward, we need to take the positive. VA minus here 1. If you convert UDL to point load, it comes downward. So 20 into at the distance of 3. So minus 20 into at the distance of 3 is equal to 0. Solve it. VA will come out as 60 kilonewton. It is moving upward. So whatever the direction we have taken for VA is correct, upward. VA is upward. It has the intensity of 60 kilonewton. Similarly for HA, summation of all the horizontal forces is equal to 0. Here we need to take right to left positive. It is moving right to left. Right to left means minus HA plus 10 kilonewton is moving left to right. Left to right means plus. So plus 10 is equal to 0. So it is 10. HA will come out as 10 kilonewton. It means whatever the direction we have taken was correct. HA is moving in this direction. HA is 10. Here if our value comes in positive, it means whatever the direction earlier we have taken was right. It indicates the direction whatever we have taken initial was correct. So this is how we need to find the support reaction. Now next what we have to do is we need to find the horizontal and vertical deflection of free end. So a free end here at point C is free end. We need to apply the horizontal and vertical deflection of this point. So for that we need to redraw the diagram by removing all the external loads of 20 kilonewton UDL and 10 kilonewton. We need to remove all the external loads and apply the unit kilonewton of horizontal and vertical at the point where you want to find the deflection. Now I will redraw. I have redrawn the diagram. So this diagram is whatever the diagram given in problem is called capital M, and this diagram is called M1 small m1. This is called M2. So here we need to remove all the external loads. I have removed here. We need to apply the unit load of 1 kilonewton horizontal. So for find outing the horizontal deflection, we need to apply the at point C unit load of 1 kilonewton. So it has an intensity of 1 kilonewton. And similarly, to find out the vertical deflection of this free end, we need to apply the vertical unit load of 1 kilonewton at point C. So it is called the moment of the vertical also, the moment of vertical one, or M2 you can call it as. It is also called as moment of the horizontal deflection or M1. You can give name anyone, whatever you want. Now what we have to do is we need to find this support reaction. So here fixed support is there. No, usually we have the three. One is vertical and horizontal, and moment is there. I will take it as anti-clockwise. First I will find out the reaction of this support. Reaction of this. So here the distance we have 4 meter, here we have 3 meter. So this is 3. Now we need to find the support reaction. See here there is no any vertical forces in this. There is no vertical forces here, so that our VA becomes 0. Here on horizontal is there 1 kilonewton. It also comes 1 kilonewton. So if it is going left to right, means obviously comes opposite direction of this, the 1 kilonewton. And now we need to find for the moment. For that, summation of all the moment about A is equal to 0. Clockwise we need to take the positive, and MA is, I have assumed it as anti-clockwise. I have taken, so minus MA plus the 1 kilonewton load. At what distance it is moving from this point to, we need to see the perpendicular distance. The what is the perpendicular distance of 1 kilonewton is 4. No, so 1 into 4 is equal to 0. So our MA will come out as 4. 4 means it is anti-clockwise. So whatever the direction we have taken initially was correct. So M value is 4. Moment value is 4. And the horizontal, I will show you how it comes. 1 summation of all the horizontal force is equal to 0. We need to take left to right positive. Here 1 kilonewton is moving left to right now, so positive 1 plus, initially we have assumed HA as moving right to left means minus HA. So minus HA is equal to 0. See our HA is equal to 1. So HA is it comes 1 means whatever the direction we have assumed initially was correct. This is how we need to find the support reaction. Support reaction of this horizontal unit load. So now we need to find the support reaction of this M2. So here also fixed end is there. 3 reaction will come. One is vertical VA and horizontal HA. Moment will come. So now we need to find the support reaction. So summation of all the moment about A is equal to 0. Clockwise we need to take positive. It is moving clockwise. So MA minus the 1 kilonewton is there. So at what distance it is moving? It is moving at a distance of 3 meter. It means 1 into 3. It is rotating anti-clockwise, so minus 1 into 3 is equal to 0. MA will come out as 3. 3 means whatever the direction we have taken was correct, it is clockwise. MA value is 3. Here there is no horizontal forces, so HA becomes 0 because there is no any horizontal forces. So VA becomes here for vertical, summation of all the vertical forces is equal to 0. Upward we need to take the positive. VA is moving upward. VA plus here 1 kilonewton is also moving upward. So 1, is there any upward vertical forces? No, is equal to 0. So now solve it. Our VA will come out as minus 1 kilonewton. Minus 1 means it is moving downward. So whatever the direction we have taken was opposite to the whatever the direction we have taken, it is opposite to it. So it means make it as downward. VA is moving downward. It has the intensity of 1 kilonewton. This is how we need to find all the support reaction. So now we have calculated the support reaction for each diagram. Now what we have to do is we need to find the moment. So by using the table, so this is the table. Here M means member. So what are the member we have? How many members we have? We have AB and BC 2 members. So write it here, AB and BC. So for AB I am taking the origin as A, for BC I am taking the origin as B. Limit of AB, so what is the length of AB is 4 meter. 4 meter is nothing but our limit will 0 to 4, and length of BC is 3 meter. 3 meter is nothing but our limit is 0 to 3. So moment, for moment we need to cut the section. X-axis away from the origin A. For AB I have taken origin as A. For AB member I have taken origin as A. So our section will come here. X-axis at a distance of X from the origin. So now we need to solve from this side to this side to this side. We need to see whatever the forces coming from here to here. So here HA is coming, so we need to take the which is moving upward positive, and which is moving downward we need to take minus. So our HA is moving upward. At what distance it is moving from this section? It is moving at a distance of X. So HA into X. So HA has an intensity of 10. So 10 into X. Write it here. 10 into X. Here moment is moving anti-clockwise. So it means minus 130. So it rotates like this now. Like this means it comes downward. So we need to take the minus 130. Similarly for M1, if we cut the section X-axis away from the origin A at a distance of X. So here the load HA is moving. At what distance from this section it is moving? It is moving upward. It means we need to take the positive. So HA into distance of X. So it has the intensity of 1 kilonewton. So 1 into X will be X. Also moment is moving anti-clockwise, so it moves like this, it comes downward. Downward means we need to take the minus 4. X minus 4. Now for M2, for AB if we cut the section X-axis away from the origin A at a distance of X. Here HA, we don't have the HA value 0, and vertical it also becomes 0. Only moment is there. Moment is moving. It is moving like this. Like this means it is moving upward. It comes like this now, rotates. So it means clockwise moving. It is moving like this. It goes upward means we need to take the positive of 3. It has the intensity of 3. So A value will write it. For BC we have taken origin as B. So if you cut the section X-axis away from the origin B at a distance of X. Here is VA is moving upward. Upward means positive. At what distance it is moving from here to here? We need to see the perpendicular distance. So for VA, perpendicular distance is X. So VA into X. VA has the intensity of 60. So 60 into X. 60 into X. HA is moving upward. So at what distance it is moving? It is moving at a distance of 4. We need to see the perpendicular distance. For HA, perpendicular is BA is perpendicular. So it has a distance 4 meters. So HA into 4. HA has the intensity of 10. So 10 into 4. 10 into 4 becomes 40. So positive plus 40. Here movement moves like this. It comes downward means minus 130. Minus 130, and here UDL is there. At what distance it is acting? So it also comes downward. So minus 20 into at a distance of from here to here is X. So minus 20 into X into it always act at a distance of L by 2. L by 2 is nothing but X divided by 2. 2 1 ja, 2 1 ja. So it comes minus 10 X square. Write it here, minus 10 X square. See, is there any remaining forces is there? No, our M completes here. Similarly for M1, if you cut the section X axis away from the origin B at a distance of X. So here HA is moving. At what distance from this section it is moving? HA into, we need to see the perpendicular distance means HA into 4. So it is moving upward, we need to take the positive. So HA into 4. HA has the intensity of 1 kilonewton. So 1 into 4 becomes 4. So 4, and here moment is there, it is coming downward. So minus 4. Minus 4. So 4 minus 4 becomes 0. Similarly for M2, for BC, if you cut the section X axis away from the origin B at a distance of X, here VA is moving. Don't know at what distance it is moving from this section. We need to see the perpendicular distance for 1 kilonewton. So this BC is perpendicular. It has a distance of X. So 1 into X. It is moving down means we need to take the minus. So minus 1 into X. 1 into X is nothing but minus X. Minus X. And moment is there. It is also going upward. Upward means we need to take the positive. So plus 3. Plus 3. So this is how we need to find all the moment for each member. So now what we have to do is we need to find the deflection of the horizontal and vertical. So this is our horizontal and this is our vertical one. So now we need to find that. I will show you by using the formula. Deflection of, now we are finding, first we will find it for the horizontal. So horizontal one, for that we have the formula integration of 0 to L capital M into small m1 is nothing but our horizontal moment divided by EI into dx. So now write all the value. For AB member we have the limit. I will take first EI outside. For AB we have the limit 4, 0 to 4 and this into this. So 10x minus 130 into x minus 4 dx plus for BC we have the limit 0 to 3, integration of 0 to 3, this into this 60x plus 40 minus 130 minus 10x square into, so this into this becomes 0 now, because here 4 minus 4 is 0, 0 into anything becomes 0, so it completely becomes 0. So we don't need to, it completely becomes 0, we don't need to write it. So now we'll solve. For vertical deflection also I will write it. We have the formula 0 to L capital M small m2, m2 is taken as the vertical divided by EI into dx. 1 divided by EI I have taken constant, I have taken 1 divided by EI I am taking it as outside. So integration of 0 to 4, 0 to 4, this into this one and this into this one. 10x minus 130 into 3 dx plus integration of 0 to 3 into 60x plus 40 minus 130 minus 10x square into minus x plus 3 minus x plus 3 into dx. So now solve it. Now I will solve for this. Integration of 0 to 4 into 10x minus 130 into x minus 4. Solve it. Our horizontal deflection will come out as 933.333. It is nothing but 933.34. So y deflection, horizontal deflection is equal to 933.34 divided by EI. So now substitute the EI value. See here, E value is 200 GPa and I value is 3 into 10 to the power of minus 4 m to the power of 4. So now we need to convert this into meter. I will show you here. E is equal to 200 GPa. To convert it into meter, we need to multiply this into 200 into 10 to the power of 6 to convert it into kilonewton per meter square. So now substitute. I value is also in meter only. They gave here, we don't need to convert because it is in meter only. 3 into 10 to the power of minus 4 m to the power of 4. So substitute here 200 into 10 to the power of 6 into 3 into 10 to the power of minus 4. So solve it. It will come out as 0.015 meter. This is our horizontal deflection. This is our horizontal deflection. And similarly for the vertical, solve it. Integration of 0 to 4 into 10x minus 130 close the bracket into 3 close the bracket plus integration 0 to 3 into 60x plus 40 minus 130 minus 10 into x to the power of 2 close the bracket and again bracket minus x plus 3. So close the bracket. Now solve it. Our vertical deflection value will come out as minus 100 minus 1522.5. So minus 1522.5. Write it here. The vertical deflection minus 1522.5 divided by EI. Now substitute the EI value here. So I will substitute minus 1522.5 divided by E value we calculated was 200 into 10 to the power of 6 into I value is 3 into 10 to the power of minus 4. So solve it. It will come out as minus 0.025 meter. This is for vertical deflection. So this is how we need to find the horizontal and vertical deflection. So here our problem ends. So I hope you all are understood this problem. So if you like the video, like it, share it and subscribe for the more videos. Thank you for watching.